Okay, so today we're going to learn about uh, graphing linear equation, linear inequality, and a whole bunch of other stuff incorporated into graphing. So before we actually start with this equation on the board, what we have to do is understand what a linear equation is, what it looks like, general form, and all that other stuff. So a slope-intercept equation, okay, remember, is y equals mx plus b, where m is our slope, which actually means rise over run. Okay, so that means we're going up or down, and then we're going left or right on the bottom. And then this b here is the y-intercept, where the y-intercept is actually where the line crosses the y-axis. Okay, so when I graph this equation, there's a couple things I need to do. One, the first step is I need to take this number and I need to graph it. So that's step one. So that is the y-intercept. So on the y-axis, I'm going to plot positive 5. I'm going to plot positive 5. Then I'm going to take a look at my slope, and my slope says I'm going to go up 1 and over 2, or down 1 and over 2. Okay? It says negative. So most of you want to go down and over 2, and that's okay. Others might want to go up and over 2. That's okay as well. With a negative slope, remember our movements are either up and left or down and right. You have to know both of those movements just in case your points or rise over runs go off the graph. You have to know the other movement so that it can actually be graphed correctly. So then I have 3 points. You only need 2 points for a line, but I have 3. So I'm going to come and now graph my line. Problem number 2 basically looks the same. It looks y equals mx plus b form, y equals mx plus b. So that is my b, that is my m. Again, I'm going to plot this number first. So negative 2 on the y-axis. My slope is 3, but I don't have a fraction. So my fraction is actually over 1. Remember, your denominator is 1 if you don't have 1. Or if it doesn't look like there is 1, your denominator is always 1. So I have a positive slope of 3 over 1. So I'm going to go up 3 and over 1, or I could have gone down 3 and over 1. Both movements are the same. So for positive slope, you can go up and right or down and left. Either one of those two movements are the same. So now I have 3 points. Again, all you need is 2. And now I'm going to graph. Okay, and there you go. There is your graph for equation number 2. Equation 3 is not in y equals mx plus b form. This is what we call standard form, where standard form is ax plus by is equal to c. So our a would be 4, our b is negative 1, and our c is 0. What I need to do is to take that equation and change it so that it looks like y equals mx plus b. And how do I do that? Well, I'm going to take my equation and I'm going to solve for y. So minusing 4x, subtracting 4x to both sides. I'm left with negative y equals negative 4x plus 0. Well, if it's plus 0, it actually doesn't need to be there. You can write it, it doesn't matter, but it doesn't need to be there. So then I have a negative y, which is negative 1 in front. So I need to divide by negative 1, or multiply by negative 1. But remember, there's a shortcut for that. So if you don't want to multiply or divide and do all that writing of fractions and stuff like that, all I have to do is flip this one, flip that one, and I get y equals 4x. So this is the equation that I'm going to graph. if I look at it, I have 4 as my M. In my B, there's nothing there. Well, since there's nothing there, it means there's a 0. So my first part right here, that's what I'm going to do first. I'm going to graph that on the 0, which is the origin. Then my slope is 4, so I'm going to go up 4 to the right 1, or down 4 to the left 1. And then I have that line. Let's go to 4. I have y is equal to 3. So this is what we call one of our special cases. So the first thing I need to do is find out where y is 3. Where is y 3? Y is 3 right here. Now, there's some other strategies to employ for this particular equation. We have to know if it's a vertical or a horizontal line. So this equation has no x. Okay, it has no x. Therefore, it has to run parallel with the x-axis. Parallel means it can never touch it. So that is my line for number 4.